Get out here and do it. We have work to do. So get out and do one of these.
What happened? No, I didn't even chip.
All right, now,
For you, I was going to write a recommendation and you're going to contact me.
we are, remember this whole packet contains 3 review sheets. We are on the first one, the first page, so we are ready for number 10. All right, and I need everyone logged in here now. We're gonna get these quizzes back after lunch, because I don't want to spoil your lunch. That's why we're waiting, all right? So some of them were not good at all. Some of them were they're not in the grade book because I didn't want to ruin your weekend.
Thank you.
So, here we go. So, I graded on Friday afternoon after school, and you ruined my weekend.
You should have just ruined ours after that. Are we on the review page?
All right. Number 10.
Is there any good scores?
Yes.
One
All right, here we go. Block n of x minus n of x. So 3x squared plus 1 minus 2x minus 3. 3x squared plus 1 minus 2x plus 3. I'm just flat out subtracting. I'll collect my terms. That is my answer, and I stop right there. All right? We're not going forward. There's nothing we need to do else. We're done. Okay, we good? All right, letter B. B says, use the same functions. This means the same as this. So feel free to rewrite it if it makes more sense to you. Well, either way, doesn't matter. They're exactly the same thing. So this means to take the entire m, which is 3x squared plus 1. So we're going to take the entire m and plug it into the x in n. Okay? So that's going to look like 3x squared plus 1 minus 3. Did everybody see what I just did right there? I took the entire m function. There's no number there, so I have to use the entire function, and I put it into n in place of the x. So then I'll distribute. And 6x squared minus 1 looks like the answer to that one. All right. And then we've got m of 4 minus n of 1. This is easy. Don't make it hard. What do we do first? Put the 4 into m. Now, do that carefully. When you put the 4 in here, what happens first? I square. PEMDAS. So 4 squared is 16. Times 3 is 48 plus 1, 49. So m of 4 is 49. And then n of 1. N of 1 would be negative 1. And then the problem says, take those two answers and subtract them. So I hope you got 50.
I did.
As the answer to that one. All right, and then m of n of 2. This is b. What does that tell me to do? What happens here?
2.
2 into n. So let's see. 2 into n. 2 into n would give me a 1. And then I take that 1 and plug it into m. So m of 1. And again, PEMDAS. 4. Make sure you're getting 4. You're doing your order of operations correctly. All right, be able to recognize and sketch the BFFs. All right, you need to be able to recognize and sketch the BFFs, okay? You need to be able to, if I say sketch this, you need to be able to do that. So what does that look like?
That's what I
Down to.
So it's a B, and you're gonna take it down to, and you're gonna label that starting point, and that's it. Okay, that's the kind of thing I need. You need to be able to recognize them and sketch them. All right. Name a continuous BFF and a discontinuous BFF.
Continuous is linear.
So, for continuous, it says name 1, but there are lots of them. Linear, or which is also identity, that would be 1. That's continuous. Why? Because when you draw it, it's one fell swoop. Right? No picking a pencil. Would this be continuous? Yep. So name a discontinuous one. No. Exponential is continuous. Exponential is continuous. Logarithmic is continuous. What? Greatest integer is definitely discontinuous because it's the one that takes the steps, right?
Pencil comes up.
There's another one that's discontinuous though. Can you think of it?
Probably
Reciprocal.
Oh.
BTAR knew it, just couldn't say the name. BTAR did not know the name.
Yeah. I lift my pencil. Yeah.
And they're also obviously.
Yeah,
3 is crazy. 2 is crazy.
he was exponential.
Yeah, but after you know all you start on this.
Number 13. Can you name the absolute maximum point on that picture? No, you can't. Why can't you name the absolute maximum?
Keeps going up.
There's a little arrow shooting up into space.
I got that wrong on the quiz.
And when there's a little arrow shooting up into space, that means the highest point just keeps getting higher.
Yeah.
So there is none. Name the absolute max.
The local
None.
max is.
None.
I just got that wrong.
Name a local max. Now,
Hey.
local maximums are tops of hills. Okay? Does this picture have a hill in it?
It does.
It does. So the local maximum is 0, 2.
If there were 2 hills,
You
would
name
you
them both.
give them both?
Yep. You can have infinitely many local maximums, right? But you're only gonna have one absolute if you have one at all. All right, name an absolute minimum. You can.
3 negative 3.
They're both going up.
Because this guy over, this asymptote over here, on this side of the picture, there is definitely an arrow. But what is that arrow doing?
To a pile.
It's getting closer to the asymptote. It isn't, it's
not
not
going down.
this. That would be no minimum.
Right.
This, there isn't, this, that's not shooting down. So you have an absolute minimum at the point 3, negative 3. 3, negative 3.
doing the exact same thing.
Now, that is also a local minimum, 3, -3. But there's another local minimum, -2, -1. There's 2 valleys in the picture. Do you see that? All right, I want you to look at the next page. It says Precal A chapter, yeah, we started a new review. It's all crowded in there. This test will not have the calculator part on it because we took a quiz over that and that counted. All right, that's it. So this review sheet has some calculator stuff on it. That isn't on the test, so I have to leave that part out. But number 1 talks about domain, number 2 talks about asymptotes, number 3 is graphing piecewise, 4 you can cross that out, that's just review, cross that out. 5 is what we just kind of did with these compositions. 6 we already talked about. 7 is vocabulary. 8, 9, 10, those we need to know. So 1 through 10 we need to know. 11 and 12 we cannot worry about. But 1 through 10, and what was the other one I said? 4. So 4, 11 and 12 you can cross out. The rest of this is fair game. So I want you right now to look through there. What do we need to practice? Pick a problem that we need to practice. Right now.
Number 2.
8.
2,
1.
Oh wait, not 8, not 8, sorry.
so 2 we'll do a couple of them. I don't want to do every single
6 or
one.
7.
But 2 talks about finding asymptotes and holes. So let's just recap real quick. If you're going to have asymptotes, you got to have a denominator. All right? And if you're going to have holes, something is going to cancel out of that denominator. Okay? So when I look at problem 2A, there is nothing. There's no asymptotes in that picture because there is no denominator. And denominators are where your discontinuities come from. So that one's easy. Now when I look at B, it does have a denominator. So it's going to have a vertical asymptote, and the vertical asymptote's going to be at -2/3. How did I get -2/3 for my vertical asymptote? I set that equal to 0 because I know that denominators cannot be 0. So x is not going to be able to be -2/3. That is my vertical asymptote. That's where the picture comes apart. Now, it also has a horizontal asymptote. The horizontal asymptote is at 0. Why is it at 0? Because the power on top is smaller. I don't have an x on the top. Therefore, my terms will continue to get smaller. All right, that takes care of B. What about C? Well,
There is no
C is going to have no holes. Why not? Nothing canceled. I could factor, but nothing canceled. There are 2 things in the denominator, so I am going to have 2 vertical asymptotes. Where do vertical asymptotes come from? Denominator, denominator, denominator. Now, if I looked at my original problem, don't I have x squared over x squared? The rest of it doesn't matter. I have x squared over x squared. So my horizontal asymptote is y equals 1.
Will we have like the x negative positive plus minus and then
You can. I boxed in the x squares. The original problem. Look at the original problem box in there. All right, let's look at D. What's happening in D? Well, first thing I notice is the power on top is smaller again. It's x over x squared.
Yeah.
When the power on top is smaller, your horizontal asymptote is 0. Every time. Now, somebody already observed I can factor the denominator, which is exactly what I should do. And then I notice, after I factor it, that I can cancel, and that leaves me with that. The fact that I cancel means I'm going to have a hole. And the hole is the factor that canceled out, which is 0. Plain X, that's a 0. Put it back in, and I get 5/4 when I put in 0. Now, I still have a denominator. That means I still have a vertical asymptote, and it will be x equals -4. And then the last one, first thing I notice about the last one, my x squareds match. So what's my horizontal asymptote? Y equals 2 over 2. When the powers match, it's just that ratio, 2x, 3x, there it is, 2/3. Now it looks like I can do some factoring there. So if I take out a 2x, I'll be left with x plus 3. What I want to do on the bottom, take out a 3, then I'll be left with x squared minus 9, which is x plus 3, x minus 3. We're going to cancel again. This is what's left, right here, this is what's left. Because I canceled, I know I'm gonna have a hole, and the hole is gonna be at the factor that canceled out. So since x plus 3 canceled out, my hole will be where x is -3. Right? Then I'll plug it in. So I plug in -3. I'm gonna get -6 over 3 times -6. Is that 1/3?
Yeah.
I still have a denominator. So my vertical asymptote is at x equals 3. All right, I wasn't gonna do all those, but I did them all. Okay, so what else do we need to look at? 5. F of x equals over x, and g of x is 2x squared. All right, so A says f of 2. Okay, come on, what's f of 2? 1, that's easy. F of x plus g of x would just be 2 over x plus 2x squared.
Yeah.
F of -3 plus g of -2. All right, f of -3 is -2/3. And g of -2 is 8. So that's -2/3 and 24/3, 22/3. or 7 1/3, if you'd rather do that, that's fine too.
Probably find them at over lunch.
Okay, we'll do that. D, F, G, of 4. Alright, but we already practiced that today. Michael, are you locked? G of 4. What's G of 4?
32.
32. So then we have to find F of 32. F of 32 will be 1/16. G of F of X. This means take the F function and plug it into the X in G. So that's going to be 2 times 2 over X squared. PEMDAS, square first. 4 over X squared. 8 over X squared. Alright, so then we need to come back to this guy right here. And the one we just did, this guy right here. And talk about domain and range. Okay? Now, the domain is not all reals. Because we have a denominator here. And if we have a denominator, we are gonna have problems. X cannot be 0. So your domain, for this problem right here, your domain is negative infinity to 0 and 0 to infinity. This is a tricky one, because this messes everything up. Does this have a horizontal asymptote? What? What's the biggest power of X I have in this problem? 1? Do I have any X's on the top? So when the biggest power is in the bottom, the asymptote is always 0. So you have a horizontal asymptote at 0, which means what? Why can't be 0? So your range is the same thing. That's an A student problem. The A students are going to get that. Tough, tricky, but the exact same thing's going to happen right here. Isn't this going to have the same domain? It sure is. X can't be 0. But this one's going to be worse. This one's going to be worse because this will not only never be 0, that can't equal 0. It also can't equal anything negative. Isn't this going to be positive all the time? So your range is actually just 0 to infinity. Your domain is everything, but your range is 0 to infinity. This one can be negative. This one is not. This part will be positive, but that part could be negative. That's tricky. All right, one more. 3. Graph the following. All right, so it's a piecewise function. Do you want to do A or B? All right. So here we go, we'll go to lunch as soon as we get this guy done.
Bro.
Just go to one.
Alright, this thing right here is broken, and it's broken where x is -2. So I'm gonna indicate that with that little squiggly line. It's like if you crack a plate on the floor, that's a fracture right there. Alright, now, what does absolute value x look like? That looks like a V from the origin, right? Now, obviously, it's broken right there. That dot is open, and I'm gonna keep the left. So I'm just gonna erase this part right here, don't need it, not part of the answer. Keep the left. What is that?
It's a linear, but it's up.
That's a linear, it's up one, but be careful, it only happens when x equals -2. So it's just a point. It's the point -2, -1. See that, guys? It says, let x be -2, and if we let x be -2, then y will equal -1. And that's it. It is the whole line, but we would erase everything except that point. And then, we got a trusty parabola at the origin.
Everything to the right.
It's broken right here, open dot. We're keeping all that, so we're gonna get rid of this little arrow right here. And then I'm gonna go ahead and erase my crack, but you don't have to. There would be the answer to the question. Now, notice, see how your dots are all lined up?
Yep.
One of them's solid, only one can be solid, because this has to be a function. All right, I'll see you back at 12:30. Because it's equal. There can't be, it has to pass it over. I found there's our house. That is an equals, that's not, that would be a solid dot, that would be an open dot.
Okay, that's all I'm saying.
I'll make up my clues. Wednesday tomorrow, so.
Yes. Yep, no, I'm giving you back a quiz when you get back from lunch.